My name is Mike Millard. I'm a consulting with IGS for about now almost 3 years. I was brought in because UOP, the company I worked for a long time, had a cooperation with Cetek, which is the ceramic coating product that IGS has, for reforming applications. And reforming is how you make high-octane gasoline in a refinery. And one of the concerns is, as these reformers operate, they develop scales on the tubes, and it reduces the efficiency of heating in the heaters. So you either have to burn more fuel, or you have to cut down on the feedstock to it, and you make less product. In cooperation with the Cetek product line of IGS and their team, we have coordinated efforts with UOP to work with all of the customers, the 400 units that are worldwide, so that Cetek has the opportunity to put a ceramic coating on these tubes in a reforming heater. And what that does, that means several requirements of customers these days. One is it makes the heater more reliable. There's no buildup of scale, and the temperature measurement is much better. The second thing is they're able to run the unit at a higher capacity for longer because the capacity of the heater is maintained over several years from the Cetek coating. The third one is they save fuel. And if they have higher heater efficiency from the Cetek coating versus this buildup of scale, they can actually burn less fuel and be more fuel efficient, which saves costs. And the last one, which is really important in the market today, every company is looking for this, is reduction of emissions. By having a very efficient heater, you reduce the amount of CO2 that you produce per metric ton of fuel that you produce in your platformer, the amount of gasoline you produce. So when you meet all of those four criteria, it becomes very important for the customers to use the Cetek coating on their reformers for the best operation. Recently, we were working with a company in China, and they make a petrochemical called paraxylene, which goes into PET, which makes all these wonderful bottles we use for water. And they wanted to have extra capacity in their unit. And these are very severe operations. So the Cetek team went to China, they took IRs on the tubes, they established that they had a buildup of scale on the tubes. And if Cetek goes in and cleans the tubes and put the ceramic coating on, they could increase the production between 3 and 5%, which means 250 to 400 metric tons per day additional production from that unit. And if you look at it that way, by producing that extra paraxylene that goes into the plastics, then they could basically pay for the service of Cetek in less than a 2-year period. The customer also had the possibility that in times when there's lower demand, their heater will run more efficiently and they'll save on the fuel costs, which is really important when a customer is trying to balance their economics, because every business is cyclical, all the petrochemicals, all the refining. So the benefit is when you need the capacity, it's there, but if you don't need the capacity, it'll save on your fuel expenses to produce your product. Customer was very interested in the product and they'll do it in the next turnaround.
My name's Larry Empsch. I'm responsible for the thermal efficiency group at IGS. I was thinking about a major project we got involved with in the Americas. So it's an oil and gas site. And in their situation, they have an ongoing program for auditing their furnaces and fired heaters that are candidates for the next turnaround. And so they're always looking to project bottlenecks and how to help themselves. So they called us in and we had our thermal efficiency group, those folks that do the auditing. They came into that facility and in conjunction with the site, took a look at the key heaters. So one of the heaters is a catalytic reformer. Now they happen to have 2 of them on site. This is the larger of the 2. This unit is primarily set up for gasoline reformate to blend gasoline, but there's also a component of that that's dedicated to paraxylene, so that octane is also critical for them. So they have both gasoline production limitations they have to address and octane concerns. So our business model is to go into the facility, we'll take infrared images, look at that data on a typical manufacturing day, look at that snapshot of how they operate on a typical day, and then go back in time and look at the design specs. And so between those two, there's a gap, and that's their efficiency loss. That's where they can get a win. So our responsibility, identify that gap, and then go to the IGS menu of technologies and go through that menu and decide where we can have the best win for them from their efficiency standpoint. Now, I should say that IGS technologies are all homegrown. So these are our own technologies, so we're the inventors, we're the owners, and most importantly, we're the applicator. So you're talking to the people that know where to put it and how to apply it. So that's a great tool for the customer. They get a full picture. So what do? We go back to them with this gap, we overlay the menu of technologies, and then give them a return on investment. We give them payback calculations. We give them all the things they need to understand how we can help them. Now, in this particular case, the scale on the radiant tube was significant. So they had real heat absorption, severity problems, meaning they just weren't getting the throughput. So that in itself identified a win for them. We also looked at the convection section. So we're looking at the entire heater. And so our recommendation included convection section cleaning because it hadn't been done in decades. Now there's a big win for them there from a process standpoint. The second win is we have thin film ceramic coating for the radiant tubes, which is a great replacement for the scale, which is clearly cutting their production. And then we have a high emissivity ceramic for all the refractory surfaces. So now you've got 3 scopes that fold in together. And in this case, it gave them a 13.5% production increase. So they got their production increase of 7,000 barrels a day. They got their convection section back to essentially design. So all the way around, it's a win. In the justification process, they actually went back with us and we revalidated fuel savings. So just in case they couldn't take advantage of the production increase, they had some hydraulic limitations, whatever it is, they had that as a default. And even that payback was a year. So no matter what, they were going to have their money back in a year in the most conservative estimation, and quite a bit less than that with what their real plan was, which was to increase their throughput. So again, a great audit. They had options, overlaid our technology, went back afterwards, improved it, and now they've got flexibility in that unit for the next decade, certainly the next 2 turnaround cycles. So that's a good example of how you put IGS into your facility and get a win.